the rhythmicity. Okay.
So for the rhythmicity, we look at lead 2 and see whether it's positive. And it
Okay.
looks
Now you do
positive.
see the rhythm strip right here at the bottom. Okay.
Yeah.
All right.
It looks to be positive, and then we look at AVR, and it looks to be negative, so it's a normal sinus rhythm.
Okay, so we do have a positive P wave. We do have P waves, okay, but it's rhythmic, okay? First of all, it's
Mhm.
rhythmic. And we do
Yeah.
see P wave, that's possible. It's coming from a sinus, so there's a normal sinus rhythm. Okay, rate, heart rate.
Okay, so for the heart rate, I will look at the RR intervals,
Uh-huh.
um, and it's like 4 squares, so
Well, a
300,
little bit less than 4, 3.5. So,
3.5. So 1 second. It's like 80 heart rate of 85, 86.
okay, that's okay.
So it's a normal one.
All right.
And then we should determine the axis.
All
And
right.
for this, we can look at lead 1 and AVF and see whether they're both positive or both negative. So for lead 1, it looks to be positive. For the lead AVF,
Uh-huh.
it also looks to be positive, so it's a normal axis.
So the axis, 1 positive, AVF positive, and
Mhm.
lead number 2 is the biggest one after 3 and 1. So the axis is around,
It's like the normal one, so between 0 to 90.
yeah, so it's around little bit more than 60 because lead number 2 is 60. This is the biggest one. And if you had 60, lead number 3 and lead number 1 should be identical. However, lead number 1 is smaller than lead number 3. This is why we said around 70 degrees. All right?
Okay.
Okay, go on.
Um, and okay, so for the next ones, we look at the waves and the intervals and the segments. Um, so it looks like every P wave is conducted. Okay, we need to look at the PR interval. Um, and it looks to be prolonged, so this could be um, grade 1, first degree AV block.
Mhm. First degree AV block, okay. Next one, the width of the QRS.
Um, Sorry, I'm trying to zoom in to count it. It looks to be shorter.
That's normal. It's not short, normal, okay? So the QRS complex is normal, so there is no intraventricular conduction abnormalities, okay? And the next
Yeah,
one, the ST and T, but everything is normal so far. Okay, good.
yeah.
All right, let's move to 1 or 3. That's it. Okay, and now, uh, Emily?
Um, so
Oh,
103.
barely can hear you.
Can you hear me now?
Well, try to be close to the microphone.
Okay, sorry.
Yes,
Okay.
good.
So, what we can see is the PR interval is
The rhythmic or not. This is the first, all the time.
um it's not rhythmic.
Okay, so it's not rhythmic. All right, go on.
Um, the PR interval is not constant.
Okay, so Next one, the heart rate. Okay, let's calculate the heart rate. How much should be the heart rate? So in this case, you have to take a longer interval, okay?
Yes.
So that means about, okay, five, I think it's about five, about this one. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, it's meaning about 90 or so, okay? Or not 90, 12, 5 times 12. Here, 6 times 12, 72. Okay, 72, so it's normal, okay?
Yes.
Next one. Do we have P waves?
The P wave is not is very small.
No, it's not small. That's normal. How big the P wave should be? The P wave should be 1/4. It should fit in a 1/4 of the square. Okay. So it's meaning that is 0.1, okay, less than 0.1, and the amplitude is less than 2.5 millimeters. So that's normal. That's completely normal. And it's positive in lead number 2 and negative in AVR. So that's normal. So that's a sinus P wave. Okay, go on. What is the next one? We do have P waves. Why is arrhythmic? Because
It's because it's not followed by the QRS. There
so
is like
not every P followed by QRS. We do see some dropped P wave but is not followed by QRS. What does it mean?
that there's a block
What kind of block?
in the His-Purkinje fibers.
Hmm? Say it again, please.
And like a block in the AV node.
Okay, AV block. What kind of AV block is this?
In a like a 2-to-1.
No, it cannot be 2-to-1 because if you had 2-to-1, that meaning
That means that every other beat is blocked.
so that means second degree AV block, okay?
Degree.
Because
Okay.
there are mostly conducted, but sometimes is not conducted, okay? And we do have only one unconducted bead between two conducted one. That means second degree AV block, okay? Which type of the second degree AV block we have?
The Mobits.
Mobits 1 or 2.
2.
Why? If you do have second degree AV block, you have to compare the last conducted PR to the first conducted PR. And if the last one is longer than the first one, this means Mobitz type 1. Yes?
Yes.
Okay. Width of the QRS.
Sorry?
The width of the QRS. Is the QRS wide?
No.
No, that's normal width. The QRS is normal, narrow. Fine. Axis.
The
One is positive, AVF is positive, so that's normal. Looking at 1, 2, 3, 2 is the biggest one, okay? And AVL is negative, meaning that is between 60 and 90, okay? So you can say it's about 80 degrees. All right?
all right.
Okay. Try to find an order. Yep. That should be okay. Wait a minute. I go for 105. And let's see. Omar.
Hello, Professor.
Hi there.
So first we have to check if it's rhythmic or not.
Hmm.
It's not rhythmic on the one, two, three,
It's not
fifth.
rhythmic.
Yeah, it's not rhythmic.
Good. Okay.
Then we have to check for regular sinus rhythm. So lead two and lead two is positive, AVR is negative. Then you have to check about the P waves. There are P waves. Uh, but the morphology is a bit different for some.
Yeah, it's okay. The morphology is
Okay.
about the same because the PP interval are constant is no problem. Okay, let's evaluate this part because that part can help you. Okay.
Okay.
Again, that's P, 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 P. Okay.
Yeah.
And here you can see, for example, a Missy, it is a P, but inside a T wave.
Uh-huh.
So that meaning, again, we do have a unconducted piece, and you
Yeah.
have to compare the last PR to the first one.
Okay, the last PR is longer than the first one.
Yes. What does it
Uh,
mean?
in Mobit's type 1,
Okay. Mobis type 1 AV block.
second
Okay.
degree AV block. Yeah.
Okay. QRS.
QRS is narrow, around
All right.
one boxes, small box.
Okay. QRS is narrow. Good.
Yeah.
Axis.
Axis. So the first lead is positive, AVS is positive, so is in the normal deviation. And
Hmm.
lead 2 is more positive than lead 3, so it's around 60 degrees axis.
Around 70 because lead
Uh,
number 1 is smaller than lead number 3.
Okay.
Okay, that's 70, that's okay. Now,
Yeah.
if you look at the ST segment is elevated, but we haven't
Yeah.
touched yet the ischemic heart diseases. So
Yeah.
that's an inferior MI, but
Yeah.
the next time we will deal with it one. Okay,
Okay.
that's
Thank you.
great.
Sorry,
Okay,
sorry.
yes,
Did you say it was type 1 or type 2 Mobids?
type 1.
Type 1. Okay.
Okay, and this is the next one. Okay, Ratnali.
Hi, hello.
Hi there, your turn.
Okay, so the rhythmicity
Mm-hmm,
looks rhythmic.
mm-hmm.
Um, and so normal sinus rhythm, the RR interval is
It's not a
fairly
normal
regular.
sinus rhythm. It's not a normal sinus rhythm. It's a sinus rhythm, but not normal. Because when we discuss what the normal sinus rhythm means, first of all, it's regular, initiated by the sinus P wave. Okay, so far so good. Every P followed by QRS, and the PR is normal. Here, I don't think that is matching with the all criterias.
Correct.
Okay, so that's not
Um,
a normal sinus rhythm for sure. Okay, go on.
the heart rate
Yeah.
um is around, I think, 75 or 80.
Oh, no way, Jose. Look at how many squares you have between two R's. One, two, three, four, five, 6.5. So 300 divided by 6.5, it's less than 50. It's around 48,
40.
45, or something like that. Okay? Yes?
Mm,
R interval.
the RR interval is inconsistent.
Why?
No, as in the length is consistent, but the height of it isn't.
Doesn't matter the height right now. We see the rhythmicity. You said it's rhythmic. Good, period. Next one, you have to figure out the heart rate. Because it's rhythmic, you can use the 300 divided by the number of the square. Okay, the big square. Fine. That means 300 divided by 6.5. Okay, this is what you have to do. That's it. And this is what I said, it's less than 50. Good. Go on. Next one.
The axis.
Okay, you can go for the axis, fine.
Okay. Lead 2 is
Lead
positive.
number 1 is positive.
Is positive. And
The
so
AVF is
negative.
negative. It's meaning that we are somewhere here, okay? On the left deviation, okay?
Yes.
You have to look at lead number 2.
Which is positive.
Positive, a little bit positive. So it's meaning that minus 30 and 0, okay? Here,
Yes.
okay? Next one, go on.
Then the P intervals.
P waves. Where's the P wave?
Yes, the P wave
Do we have
is
P waves?
yes.
Positive in and negative in AVR, so that's okay. It could be originated in sinus. Now, we haven't touched yet, but if you get closer to this P wave, you can see that this P is wide and the shape is nudged biphasic. This is a sign of a left atrial hypertrophy. We haven't discussed yet, but it will come. Okay?
Okay.
Go on.
Then you
Every P followed by QRS.
yes.
This P wave followed by QRS. No.
No.
This P followed. Yes. This followed.
Yes.
No. That's
No.
yes. No. Yes. So not every P conducted, but every second P is conducted only. What does it mean?
2 to 1 AV block.
2 to 1 AV block. Okay. 2 to 1 AV block. Okay. All right. Let's see the width of the QRS.
Looks normal.
Normal. Okay, so that's meaning that normal, there is no intraventricular conduction abnormalities. Next, the STT, but everything is fine. Good. Okay. All right. Let's move on. Let's move on. Okay, I have to find the next tracing. Yes, that should be the following one. Okay, come on. Yes, that's it. And who has this one? Cheyenne?
Yeah, that's me.
Okay, good. Your turn.
So first, the rhythmicity appears to be rhythmic. Now the heart rate between the QRS complexes, we see 1, 2, 3, 4, 5, 6, 7, 8, around 8 boxes, which means that is totally bradycardic.
So it's around 35 or so, okay?
Yeah, exactly. Now, okay, so rhythmic, bradycardic, and now the axes. If we look at lead number 1, that is appearing positive. AVF is negative. So that means that we're gonna have a left deviation. And now it just depends on if it's extreme or not. Lead number 2 is negative. So that will be a normal left deviation.
No way, Jose.
Oh, my bad. Extreme.
That's an extreme left deviation. Okay, so between minus 30 and minus 90. Look at AVR. AVR is positive. It's meaning that you do have between minus 60 and 90. So that's an extreme left deviation, okay?
Yes. So that's an extreme left deviation. That could mean that could be due to a hemiblock.
Okay, very good. Which one?
So if it's a left deviation, there'll be a left anterior hemiblock.
Very good. Wow.
Thank you.
Somebody studied.
Yeah, so left
Okay.
anterior hemiblock. If now we look at the P waves, there are P waves. Now, if they are originating from a sinus rhythm or not, it could be, if we look at the lead number 2, it's positive, AVR is negative, so they do come from a sinus, from the sinus node. Immediately, it does appear that not every P wave is conducted.
Okay.
It actually seems that most P waves aren't conducted.
Exactly.
So that's a
Meaning
high degree block, AV
very
block.
good. And the ratio is?
The ratio, it is more than 2 to 1. I mean, it's just one. This first one is conducted. The next one isn't conducted. The next one isn't conducted, and then the next one is conducted.
So we have
Uh,
4 Ps,
4 Ps,
and
and only
out of the 4, only one is
one,
conducted.
only one. So 4 to 1.
Exactly. Good.
So I
QRS.
think that's about it. Oh, the QRS is the QRS widened, so it's an escape
Very
rhythm.
good. No, 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 no,
No
no,
escape
no.
rhythm.
No, you
No.
had 4 to 1 AV block. Okay, this is
4 to
not
1
an
AV block.
escape rhythm. If you
Okay.
had an escape rhythm, it means you had a
Like,
3rd-degree AV block. There
okay.
is no connection between P and QRS, but here you have.
Okay, so that's that'll be like a complete. It has to be like a complete AV block for it to be escape rhythm.
Yes,
Okay.
but this is not.
Okay. Thank you.
So
Oh, my bad.
QRS is
My
wide.
bad. Yeah, QRS is wide here, so that's a intraventricular abnormality.
Mm-hmm.
QRS here as well. I think what you're getting at is we're looking at bundle branch.
Which one?
Bundle branch block. So V1 here's positive, and in V6, we're just looking at V1, right? Not
Yeah, you
V6 is
can
negative.
look at, okay, doesn't matter. V6 is positive here, but the negative part is a little, as you see here on the left side, as a deeper or wider S
Oh,
wave that we do have. But the
yeah.
R complex is in V1, so
Oh, it's a left bundle branch block.
no.
Right bundle branch block.
Whenever you do see the
Yeah.
R complex, the block is there. This is the right side, okay? Right side. So this is a right bundle branch block, okay? Plus,
Okay.
you said the left anterior
Oh,
hemiblock.
and then there's a is it a the A R the PR interval on the conducted beat is prolonged? Is it a trifascicular?
I don't think that
Or
is
just
prolonged, but you can see it as a trifascicular block is
yeah.
fine, okay?
Okay.
Because we do have a right bundle, left anterior, and an AV block, so that's a trifascicular block. Okay, good.
Okay.
Very good.
And
Okay.
just a quick question. You said because there is the R complex. Is this showing that it's a right bundle branch block because of the septum being the depolarization of the septum? Or is that the explanation? Because
No,
left,
no, 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 no,
no.
no, no. This is the R complex because, as you remember, okay,
Yeah.
okay, this is the ventricle activation.
Mm-hmm.
Normally, this is the right and this is the left side.
Mm-hmm.
Okay. If there is no right side, what
Mm-hmm.
happening? You do have a normal septal activation.
Mm-hmm.
After you do have the left ventricle is activated, and later on, the
Mm-hmm.
right side is activated later. This is
Mm-hmm.
why you do have a initial
Oh.
R and S, and the next one, when the right ventricle is activated, that's a R wave.
Oh, okay.
Okay?
Okay.
This is
Yes.
why you do have an RSR. And another side, if you're looking at, for example, the left side, the first one is completely okay. Next one, the left ventricle activation is okay. But
Mm-hmm.
here you do have a little bit wider S wave. This
Oh,
is
okay.
why it's coming for the right bundle branch block.
The right
Okay?
bundle branch block. Okay. And the left bundle branch block, you just have the
The
RSR.
left
Okay.
bundle branch block is different one. Okay, I show you that one as well. Okay.
Mm-hmm.
And everybody should watch now. Okay, good. So, because we do not have, okay, I try to draw a color. Okay, oops. All right,
Mm-hmm.
color. So the left side is blocked, okay? So left side is blocked. It's meaning that the septum is activated from the right side, okay? From the right side. After you could have a little along, let's say, activation of the right side, but everything goes toward the left one. So what does it mean? You will start with negativity. You can see a little notch, but sometimes you don't see any notch. And on the other side, on the left side, you do see a wide and notched R wave. This is the left bundle band block.
Okay.
Okay. Good. All right, let's move on. Yes. 109. 109. Okay, let's see. Toxham.
It's Tokjan.
Toxham.
Yes. So we need to find is it rhythmic or not. So this is rhythmic.
Okay.
We see P waves here.
Okay.
Heart rate is so I 7 blocks, so 300 divided by 7, 42 beats per minute. So not every P wave followed by QRS.
Look, if you do have rhythmic heart rates, okay, that's rhythmic.
Yes.
And if you're assuming that not every P followed by QRS, somehow it's more likely that's be arrhythmic. Okay, but this is rhythmic. We do see P wave, however, okay? We do see P wave. Let's look at the P waves, okay? This is a P for sure. That's a P, that's a P, that's a P, that's a P, that's a P. What does it mean?
So they follow by Q. But so there's no QRS then?
No, we do have QRS. But the question is, this QRS is initiated by the P wave from the atrium or not? What is the criteria for this? If you do have a supraventricular rhythm, and if you do have a SA rhythm, the PR interval should be constant when we do have P followed by QRS. Okay? So you should show that the P is followed by QRS. And look at, this is a very narrow, the PR interval, almost none. Yes? Here you do see the P inside the QRS. So I would say there is no connection between the P and the QRS. What does it mean? What does it?
It's like the pattern, the Mobitz type.
No. Look, Mobitz type is a second degree block, and there is not rhythmic, and this is rhythmic, and we said that there is no connection between the P and the QRS. So what can be?
Like
for sure is not a first degree, because every P should be followed by QRS. Okay, second degree, mostly conducted, so we do have a P followed by QRS, but sometimes only one bit is not followed by QRS. That's arrhythmic. You can have high degree AV block when you do have mostly unconducted Ps, so independently working Ps and QRSs, but sometimes you do have a connection between, so that means arrhythmic. And when do you have, Babi?
Okay.
So
this is arrhythmic.
So this is rhythmic. The RR interval are constant, not?
Yes, they are.
So
they're rhythmic.
So first degree, not rhythmic. Second degree, Mobitz 1, Mobitz 2, not rhythmic. 2 to 1 is rhythmic. 3 to 1 or high degree is rhythmic when you do have a proportional. But this is not at all. There is no rhythmicity in this P conduction. So that means a third degree AV block. So the
Oh,
block. And you do have a escape written originated from the junction. So that's a junctional escape written with a third degree AV block.
okay.
So
Right.
please watch the movies and you have to practice. All right.
Okay.
No, let's see. Let's continue. All right. Let's see the next one. Wait a minute. 110. Okay, 110. And that should goes to, I think is Emily.
Yes. So
Huh? Yes?
so for uh the rhythm is regular.
Yes. So it's rhythmic. Okay. Go on.
Um there are the P waves before the QRS and the
So we do have P waves.
no. Oh yes. It's
Yes, we do have P waves. Okay. You can see P waves. All right. That's fine so far. Now you have to see where are those P wave. Okay. That's the easiest one, for example, to see here. This is the PP interval. All right. And now if I go here, I can see some P's that inside the QRSs. What does it mean? And the PR is completely independent, it's not the same. So what does it mean?
like that there's a left axis deviation.
No. Don't talk about axis left.
Okay.
You started with the P wave, and we said that there are P wave, but the atrial rhythm is independent from the ventricular rhythm, meaning we just had an ECG with the same. So
I'm sorry, can you repeat?
that's a third degree AV block again. That's a third degree AV block because the atrial rhythm is independent from the ventricular rhythm. The PR is not the same or is not correlated with the QRS complex, okay? And is rhythmic. So that's a third degree with a junctional escape rhythm because the rate is very slow, okay? The rate is around, if I calculate, about 40. Axis.
Um, it's uh, uh, it's left axis deviation. The AVF.
No way, Jose. No way, Jose. Lead number 1 is positive. AVF is positive, meaning that's normal. That's completely normal. Between 0 and 90 degrees. Which is the biggest one in 1, 2, 3? 2. Okay? So it's around 60, but lead number 3 is bigger than lead number 1. This is why you should say that's 70. Because if you had a 60, 1 and 3 should be equal. So that's around 70. And one thing is the QRS is wide.
Yes.
Not wide. Because from the beginning of the QRS till here, that's an ST segment. And this is a T wave inside. And the next time we will practice with this one, that's an ST elevation only. Okay, that's an ST elevated MI. So that's a QRS is narrow. You can see that is narrow, this QRS. Okay, let's move on. Okay, I try to. Yes. Okay. 100 and okay. 112. Okay, that should be Maria.
Okay, so first of all, we have to look whether it's rhythmic or not. And for this, we have to look at lead 2 and AVR. So for lead 2, it's positive, and for AVR, it's negative.
Okay.
So that would be a left axis deviation.
Why? What? I cannot understand these things. Look, rhythmicity. Looking at the RR interval. Okay, that's constant. It's rhythmic. Next one. Do we have P wave? Yes, we do. Okay. Positive in lead number 2, negative in AVR. So this P could be originated from a SA node. Good. Period. Next one. Is this P is connected to the QRS? Every P followed by Q wave?
No.
No. So mostly not conducted, sometimes conducted, because if you're looking at these PR, is about the same, yes? And it's proportional. And if you can see that this is 1, 2, 3, out of 3, we do have only one conducted, so this means 3 to 1 AV block. Okay. Next one, QRS. Okay, let's see the axis. Let's see the axis. How do you do the axis?
You look at lead 1 and AVF.
Okay,
and
lead
see whether
1 is?
lead 1 is negative,
Okay.
and AVF is positive.
So what does it mean?
It would be a right deviation.
Exactly. Right deviation. AVR? It's about the same, perpendicular, so it's meaning that this is 120. So that's a
Right.
pathological right deviation, extreme right deviation, all right?
Yes.
And the QRS is, let's see, wide, but extreme right deviation could mean that's a left posterior hemiblock.
Okay.
Good. Next one, QRS.
The QRS and they don't look the same.
What do you mean?
Like some are wider and some are more narrow.
All the way is wide, but you don't know the beginning and the end of the QRS. It's okay. Look at in V1. What did we say so far about in V1? You do see this kind of pattern. What does it mean when you do have this kind of pattern in V1?
Is it when the P wave is also part of the QRS?
No. What? This pattern that you can see here, this RSR pattern, what does it mean? This is the third or the fourth time that I'm explaining it. If you do see this M complex, RSR complex in V1, what does it mean? Right bundle branch block together with left posterior hemiblock. What does it mean? This is bifascicular block so far. And because we do have an AV block, This is the trifascicular block.
Okay.
So, guys, you should follow and you should practice and watch the videos. And if you do have question, you can ask question anytime. But if you are not doing anything, you won't learn it for sure. Let's move on. Okay. I try to find a good one for the next one. Okay. No, I do. Ah, yes. Let's look at this one. It's 19. Okay. And Omar.
Hello, Professor.
Hi there.
So first we need to check the rhythmicity,
Mm-hmm.
and the RR intervals are constant, so
Mm-hmm.
it's rhythmic.
Mm-hmm.
Then we have to check for regular sinus rhythm.
Is
We
rate.
can
First of all, let's calculate the
the
rate.
rate. Okay, so it's 1, 2, 3,
3.
4, or 3 or 4. So you have to do
3.
200 divided by 3, so that's 100 beats per minute.
Exactly.
So is it tachycardic?
Okay, good.
Yeah.
Do we have
So
P waves?
yeah, now we check for regular sinus rhythm. We have P waves. Yeah. Uh, lead 2 is positive, AVR is negative, and you have
Mm-hmm.
to check if every P wave's followed by a QRS complex.
Mm-hmm.
Uh, yeah.
Okay.
So it's
And
regular.
the duration or the PR interval is about 0.2, so that's okay.
Yeah. Then we can check the QRS complex. Oh, we can find
Mm-hmm.
the axis first.
Okay,
So
doesn't matter.
okay, so lead 1 is positive, AVF is negative. So you go to the left side deviation. Then you can,
Why?
oh wait, AVF. Oh no, then you
Oh,
check
no,
lead
yes, left
2.
side, left side. I'm right.
Yeah,
Yes, you are
left
right,
side. Yeah, left
completely.
side. Yeah.
Yes.
Then check if lead 2 is positive, and that shows left side deviation. Yeah.
But this
Uh,
is lead number 2 is
is it equiphasic more?
okay, more equiphasic, so it has to be a minus 30.
Yeah.
Okay.
Then we can check the QRS complex.
Mm-hmm. Is it
It's
wide?
yeah, yeah, it's quite wide. And V1 is wide, so that can suggest a right bundle branch block.
No,
Oh,
no, please. It's very simple. You don't need to think too much about it.
okay.
Let's look at V1. Okay, let's
Mm-hmm,
look at V1 only. When you do have a right bundle branch block, you do see this.
mm-hmm,
If you do have a left bundle branch block, you should see this one in V1.
mm-hmm,
If you do see right bundle branch block on the left side, you should see a wider S wave. When you do
mm-hmm.
see a left bundle branch block, you should see this kind of pattern on the left side.
Okay.
So what do you think? Which one?
Uh, it's the left side, left bundle branch block.
Yes.
Yeah.
So whenever you do,
Is
yes,
the M complex only in V1, or do you have to see in V2 as
wide
well?
R wave, not the M complex, wide
Okay.
R wave. Whenever you
Okay.
do have the wide R wave, the block is there.
Okay.
If you do
Okay.
see the wide R wave on the right side, right bundle branch block. If you do
Okay.
see the wide R wave on the left side, left bundle branch block.
Mm-hmm.
Okay.
Mm-hmm.
And which are the left leads? Lead number 1, AVL, for example, V5, V6. But here, basically, you don't see nicely. And this is
Mm-hmm.
why you should go for the V1 and the V1 and the left side.
Mm-hmm.
So that's a left bundle branch block.
Okay.
You don't like the blocks. None of you like the blocks. I don't know why. Okay, wait a minute. I delete it and I'm going. Okay, here it's difficult to determine the time, but hopefully we don't need it. Okay, Ratnali.
Okay. So
Oops.
it's arrhythmic,
Good.
and the axes are sorry, the axis would be lead one, which is positive, and then you go to ABF, which is also positive. Yes. So
Yeah.
it's normal,
Mm-hmm.
and
Lead number 3 is about equiphasic. What does it mean?
yeah. Um, that it's at 90.
30. 120 minus 90 means 30.
30. Okay.
Okay.
Then I look at the P waves.
Yes.
Um, and there are
So
no
there is no P wave. Good.
P waves.
What does it mean? Read me
Um,
a no P wave.
Atrial fibrillation.
Very good. Very good. AFib. Good. Okay. Next, QRS.
Um, Maybe wide.
And
Um,
look at
and
V1, V6, or bleed number 1.
we want uh is wide, no?
Yes, it's wide.
Okay. So you have a supraventricular formation, impulse formation.
Yeah, because we have atrial fibrillation. That means
Okay.
supraventricular rhythm. And why the QRS is wide?
Uh, the conduction abnormality,
Intraventricular conduction
intraventricular
abnormality. Which bundle is blocked?
the right, right one.
Yes, because you do see this wide R wave in V1 and the deeper S wave in on left side. So that's a right bundle
No
branch block
block.
plus an atrial fibrillation. The axis was normal, so it's fine. Okay. All right, let's move on. Wow. Okay, next one is a very nice one. Okay. Cheyenne?
Yes.
Okay, it's yours.
So first the rhythm looks arrhythmic. Can you hear me? Sorry, but can you hear me?
Nothing. Yes, I hear
Oh yeah.
you. I hear you.
Sorry.
It's okay.
Okay,
Good.
okay.
Go on.
Yeah, so it's arrhythmic, the rhythm. Then we to calculate it, we can calculate the number of QRS complexes in 1 minute. So
In 1
having
minute you cannot calculate it, but you can calculate with
sorry,
6 seconds, for
sorry,
example.
my bad. Yeah, my
Okay,
bad.
6 seconds, it's
Six
around
second.
70. It's okay, 70.
Yeah,
That's fine.
my
Good.
bad.
Go on.
Okay, and then next the axis can be
Okay.
calculated. So positive in lead number 1. AVF is also positive. So that's a normal
Okay.
normal axis. AVL is positive or equiphasic.
Equiphasic. So that
Equiphasic.
means
That means 60
good.
exactly.
Very good.
Now the P waves.
Mm-hmm.
There are P waves. Every P wave is followed by a QRS complex. However, so that every P wave is followed by a QRS complex. If you look at there's a there's a um here it's eliminated, which is a I'm just trying to figure out
But
the word.
however, in some part we have no P wave. What
In
does it
some
mean?
parts we have no. Oh, it's a nomotopic impulse abnormality.
So,
So it's a problem with the sinoatrial node. It's not
so
normal. So this is a Sorry, just give me a second. Um, mm, I'm just trying to figure this out real quick.
No P wave.
No P wave. So let's say it's a normal topic. It's sinus arrest.
Or that can be sinus arrest. Very good. That can be sinus
Yes.
arrest. Or
Or sinus. It's just a normal sinus arrhythmia.
or what kind of conduction abnormality?
What type of conduction abnormality? Um, uh, it wouldn't be atrioventricular because there's no P wave.
Yeah, so it cannot be AV block.
It can't be an AV block. It has to be a
SA block.
SA block.
Exactly, SA block. Okay.
Yes.
So
Is a
that's
sinus
some.
arrest? It's not the synonym, right? Sinus
No,
arrest
no,
and
no, no.
SA
No.
block.
What is the
Okay.
difference between sinus arrest and SA block? What is the difference
Oh,
between
the
these two?
sinus arrest is that there's no impulse formation, but the SA block is that there is no conduction
Sinus
between the
firing,
SA.
but the impulse not getting out from the sinus. Okay.
Okay, so that's the SA block.
Okay. And there are
And
two types.
there's the Mobitz
Mobitz
type
type
1
1 and Mobitz type
and the
2.
Mobitz type 2. So the Mobitz
How can you determine whether it's Mobitz type 1 or Mobitz type 2?
it's by the if the last conducted if the last RR interval is 2 times as the last conducted,
Okay,
and
let's see.
it's not it's
Let's see. 1, 2, 3, 4, 5, 6, 7.5. Okay.
yes.
1, 2, 3, 4, 5, 6, 7.5.
So it's not
So,
twice as long. So it's Mobitz
so
type 1.
exactly
Yeah.
twice as long.
Oh
Because
my bad.
I
Yeah, there's a P
counting
wave in between.
2.
Yeah,
Yes.
yeah, yeah, yeah. There's a P wave. There's a S.
So,
Sorry, QRS in between.
so that's
It's Mobitz type
Mobitz 2.
Mobitz type 2.
Okay.
Okay. Okay.
For sure. That's Mobitz type 2. Okay.
Okay.
Next one. Width of the QRS.
It's normal width.
Good.
Normal
Very
width. So
good.
there's no
So
intraventricular
no
abnormality.
conduction abnormality. Very good.
Okay.
Okay, good. All right.
Mhm.
Okay, I can see that you studied, but now a little bit confused. But it's okay. Keep studying.
Yeah,
That's
yeah.
good.
Thank
Good.
you.
Okay, 126. All right, good. Let's see. Oops. No, 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 no. Okay. Oh, I think it's Toxam.
Tokjan, yes.
Tokjan, yes. It's yours.
So this is regular, but very slow rhythm, I think.
Is it
Uh,
regular? Is it regular?
I mean rhythmic,
This is
right?
consequent. This is consequently recorded tracing. Okay, this is consequently recorded tracing. Doesn't matter. This could be
Mm,
lead number 2, all of them, and this means is arrhythmic for sure. Sometimes it's rhythmic, but sometimes it's not rhythmic. Okay, this is what you can.
okay.
All right, now this is. Let's
Then
consider that that's as a p pong.
so it's really small heart rate.
It's not a small heart rate because if you do calculate the average, it's not bradycardic. This is about normal. You can count it if you wish,
uh,
but I don't think that
like
is so slow because
like
this is
40
it's
beats
faster.
per minute.
Okay, let's calculate it. Let's calculate. That's the best one. Okay, let's go. But let's go for this one. 1, 2, 3, 4, 5.
Oh,
1,
60 so.
2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many we have? 1, 2, 3, 4, 5. Another one. 1, 2, 3, 4, 5. 6 seconds. 1, 2, 3, 4, 5, 6, 7, 8. That means 80 bits per minute. Okay, 80 bits per minute. So it's not
80,
bradycardic,
okay.
it's normal. Okay.
Okay. Mm, So
Let's go for this interval that you can here see. This is the normal PQRS, PQRS. Here, there is no P. Yes? And we
yes.
do see this very similar to the previous one. That's an assay block. But now you have to look at this distance and compare to this one. And as you see by your naked eye that this is longer than this one. We can count it.
Mm-hmm.
That means this is an assay block, Mobitz type
Mobitz type
1.
Mobitz one second
Okay?
degree.
Yes, assay block. Okay, good. Let's move on.
Sorry, just one quick question.
Okay,
Can you just remind me how you can tell if it's a sinus arrest or essay block? How you would?
basically, you cannot say it. You
Okay,
cannot see it based on the 12 lead ECG because you do not have any kind of clue that whether the sinus was activated or not. If you do have an esophageal ECG or intracardial ECG, you could see it.
okay.
All right.
Thank you.
So,
So there is no sinuses? Sorry.
what?
Is this graph have sinuses or no?
Yes, this is sinus
Okay.
written. These are the sinus P wave. And this is no P. So this is what he asked, whether this is a sinus arrest or SA block. And how can we distinguish based on the 12 lead ECG? And I said, we cannot. But let's assume that the SA block, okay?
Okay.
All right, let's go for, that's it. Okay, and Emily again.
Hello.
Rhythmic or not?
It is rhythmic.
Good. Heart rate.
Um, so we will do 300 divided by 25.
4.
Or sorry,
300
divided by
divided
4.
by 4, this means 75.
Yes.
Okay, because we do have 4 large square between 2 R waves. Okay, so that's normal. Okay, next one.
Um, uh, the P waves are
Do we have P waves?
no, they are absent.
We
But
do have P waves.
they're small.
But what is the problem with this P wave?
It's not related to the QRS.
It's related to the QRS, but exactly the opposite. You do see negative P wave in lead number 2 and positive in AVR. What does it mean?
I'm not sure.
Yes, you sure. This is a junctional rhythm because the atrium is activated the opposite way.
Oh,
That's a junctional, is not an escape one because the rate is 75. So that's a junctional acceleration. Okay,
okay.
axis.
The lead one is a positive axis, and AVF is also positive.
AVF is equiphasic, 0, I draw it. So,
So there's a left axis deviation.
no, AVF is equiphasic and 1 is positive. So that means the axis is 0. Normal, axis is 0. QRS.
Um, QRS is wide.
Yes. And
And um it's smaller in lead one.
look at this pattern. What you do see in V1. What does it mean?
It's positive.
What does it mean? This RSR pattern.
Ventricular contraction.
We said that's a junctional rhythm. The QRS is wide, so we have an intraventricular conduction abnormality. So the impulse gets to the ventricle, to the normal conducting pathways. But because the QRS is wide, we do have a problem inside the ventricle. Do we have a right bundle branch block or left bundle branch block? This is the question.
Left.
Because you do see V1 and RSR pattern. In this seminar, this is, I think, the sixth case when I explain this. Whenever you do have the wide R complex or the right side or left side, the block is there. V1 is a right ventricle leads. So that's a right bundle branch block. Have you watched the conduction abnormalities?
Yes.
Okay, you should watch it again. And you should
I
practice.
will. Yes.
Yes, you have to. You have to understand and you have to follow it. Whenever you do see the M complex, the block is there. Okay, and this is a right bundle branch block. So you do have a junctional rhythm with a right bundle branch block. Okay, let's move on. Doop, 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 doop. Yes, that's a good one. Okay, all right. I think it's Maria is the next one. I know by heart.
Yes. Okay, so first we look at whether it has a sinus rhythm.
No, rhythmicity.
Let me see. Yeah, it looks to be rhythmic.
This is rhythmic. This is arrhythmic. You can see it right here that RR interval is not the same. So it's arrhythmic. Okay. Is there any P wave?
I think so.
Where? You can use your cursor. Do you have a mouse?
Yeah.
Okay.
I don't think there's any.
Okay, I try to. Yes, remote control. Yes, I can give you the remote control. Yes, okay, now it's yours. Left click, and after you can use my cursor. Doesn't work. You cannot move my cursor?
No, I don't think so.
Okay, no problem. All right, so no P wave. Here you do see some waves, but this is very rapid.
Atrial flutter?
No.
Fibrillation?
What is the difference between flutter and fibrillation? The rate of the atrial frequency is if it's over 350, that means AFib.
Yeah.
If it's less than 300,
It's flutter.
that can be flutter. And that should be this kind of waves, okay?
Mm-hmm.
And you don't see this. That's a
Mhm.
flutter. That's a fibrillation. So we
Okay.
do have atrial fibrillation. Okay,
Fibrillation, yes.
go on. QRS, is it wide?
Yes.
Okay, so we do have a supraventricular rhythm and we do have a wide QRS complex. So what does it mean?
Would it be a left bundle branch block?
Yeah, we do have an intraventricular conduction abnormality, and we have to look at V1 and V5, V6, and immediately you can see that's a left bundle branch block. Wow, finally, great, I'm happy. Axis?
Okay, so for the axis, we look at lead one and AVF. So on lead one, it looks to be positive, and lead AVF, it's 31,
Equiphasic.
it's negative. Yeah, it's zero,
So
sorry.
the axis is 0 degrees.
Serious.
Good, very good, finally. I'm happy. Okay, good. Now let's move on. Let's move on. Let's move on. Okay. Oh, yes. Okay, that should be
Hello, Professor.
Cheyenne. Yes, oh,
Oh,
no, Omar. Omar,
yeah,
yes, you
sorry.
already. Great.
Yeah, sorry. Yeah, so is it so this one, right?
Mhm,
133. So first we had to check the rhythmicity,
mhm,
uh, and it's rhythmic.
mhm.
Then you got to check for normal sinus rhythm. So lead two is that equiphasic? It's not really.
Yeah, okay. Now we are going for the sinus rhythm or going for the axis. Which one that you want to do?
Oh, normal sinus rhythm. So you have to first
Okay.
check
Do
for
we
the
have
P
P
wave.
waves? Do we have P waves?
Yes.
Okay, positive in lead number two, negative in AVR. Good. And every
Okay.
P should be the same and followed by QRS. So that can be a sinus rhythm. Period.
Okay. Okay. Uh, we can measure the axis now.
Yes.
Lead one is positive. AVF is negative. So just left deviation. Uh, yeah, left deviate is AVF negative. AVF is negative, right?
AVR negative, but lead number two is
Oh, lead number two is negative as well, so extreme
so
left deviation. So you have to look at
exactly. What
AVR.
does it mean when we do have an extreme left deviation?
Anterior hemiblock.
Okay.
Yeah, left side
So
anterior
we
hemiblock.
left
Yeah,
anterior hemiblock. Good.
yeah.
Next one, PR interval.
PR interval. It's it's constant.
And
Uh,
and normal.
normal. No, yeah, normal.
Okay. Good. Next, QRS. Is it wide?
No, I don't think so. No. Oh, in V1, yeah.
And everywhere, not only in V1, but in lead number one as well, because here this is a QR interval. Okay.
Oh, okay. Wait, so for lead one, how exactly do we measure it? Because how do we know the difference between the QRS and then the ST area?
Okay. Very good. Okay. I show you.
Yeah.
Okay. Good. I'm magnifying it. And
Okay.
from the beginning of the QRS
Yeah.
till this J point.
Okay. So it's
This
okay.
is
Okay.
five
Okay.
starting. Okay. Here
Okay.
as well. Here this starting.
Okay.
And
And
here
on V,
that's starting.
yeah, and V1, you can see the RSR shape.
Yes.
So is that a right bundle branch block?
Don't ask. Say it.
Yeah. Yes, it's a right bundle branch block.
That's a right bandu bench block and the
Yeah.
left anterior hemi block. What does
So
it mean?
bifascicular block.
Okay, that's a bifascicular block. Very good.
Yeah.
Okay, slowly, slowly. And then, yes, okay. The next should be Cheyenne.
Yes, hello.
Hi
Um,
there.
so first there's a rhythmic. It's
Mm-hmm.
rhythmic. We have clearly three boxes in between each R interval. So that's 100 beats per minute.
Okay.
100 beats per minute. I believe it's still okay. 60 to
Tachycardic. You
100.
can say immediately.
Tachycardic.
Tachycardic. Tachycardic.
Tachycardic.
Okay.
Now next the axis.
Mm-hmm.
Lead number one is negative, so we're
Mm-hmm.
already on the right side. AVF is positive, so that shows that we have a right. AV is positive. AVR is also positive, so that is an extreme right deviation.
Mm-hmm.
That means that we have a left posterior hemiblock.
Mm-hmm.
Now, next, the P waves.
Mm-hmm.
I can see P waves in front of every QRS complex. Um,
You
oh
cannot
no,
or you can.
I cannot.
You can.
I can.
Believe me, you can.
Okay, but if you look at lead number three, you see that
But
where's the T wave?
where do you find the P wave? Lead number two or V1? Okay.
Okay, so P waves only lead number two and V1.
No,
That's
no,
where you
no.
look. Oh, sorry.
Everywhere you can look at the P waves. Everywhere. But these
Okay.
are the two places where you can see much
Oh,
easier
if it's
the
a
P wave.
sinus. Okay, okay. And it's positive in okay. So in lead number two it's positive and and V1 is negative. So that should be a normal
Okay.
sinus rhythm.
No, it
So
cannot be a normal sinus rhythm.
because it's tachycardic, my bad. If it's tachycardic, it can't be normal. Is that the
Okay.
explanation?
That's a sinus rhythm
It's sinus
only.
rhythm, but it's not
Don't say that's
normal.
a normal sinus rhythm.
Okay.
Okay.
It's a sinus rhythm, but it's not normal because it's tachycardic.
Exactly.
Okay.
Yes.
Okay. Um now is each the it's a prolonged um
Okay. So the
ER
PR is
interval.
longer because it's 1, 2, 3, 4, 5, and a little bit more. So it's a little
Yes,
bit more than 0.2.
but
Okay.
every P wave is getting conducted and
Okay.
it's just being prolonged. So that's so already it's an AV block and it's a first degree AV block.
Okay.
First degree AV block with a left posterior hemiblock that already points towards a
If we
trifascicular block.
do have a right bundle branch block, if we had it, yes. Do we have it?
Oh, do we have a right bundle block? In V1 there is a RSR complex. So we have a right bundle branch block
So
and
that's possible. It's a trifascicular block because we
trifascicular
do have
block.
a right bundle branch block. We do have a left posterior hemi block that makes a
Mhm,
bifascicular block, and the
mhm.
AV block, the first one means that we do have a
Yes.
trifascicular block. Okay.
And just quickly, I know you've explained this already. With the right bundle branch block, it's okay now. Just so with the right bundle branch block, you look at V6 for the long S interval as well, for the long S
Yeah.
wave, and
Yes, the deep and the wide S wave.
in
Okay.
V1 you look for the RSR. And
Yes.
just quickly for the left bundle branch block, what I wrote down, I don't know if I quote that correctly. I wrote down that it's a left bundle branch block if we have a supraventricular rhythm plus a intraventricular abnormality.
Yes.
Um, and that's would that be the explanation enough? If we just see a supraventricular rhythm because of an AFib or something, and if we
Yes.
see long RSR, long QRS complexes
Yes.
wide. Okay, that's
Yes.
enough. Okay.
Yes. Yes.
Thank you for
That's it.
keep.
So we're
Perfect.
proving that the supraventricular rhythm that can be sinus rhythm, can be
Hmm.
atrial rhythm, can be junctional rhythm. Okay?
Okay. Okay.
These
Okay.
all means supraventricular rhythm.
Hmm.
And if the QRS is wide, after you can say that's an intraventricular block.
Okay. Perfect. Thank you so much.
Okay. Good. All right. Okie doke. Let's go to the next one. Mm, 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 mm. Momento. Yes. Okay. This should go to Tagjam. Tagjam.
Okay, so I've
Okay.
wait,
You are exhausted completely.
sorry. Wait, wait. Um So this is I think this is a regular rhythm.
Good.
A normal heart rate. Um, so P waves are present.
So 3.5, it means we do have about 80 or 85, okay? We do have
80,
P
yes.
waves in front of every QRSs, that positive in lead number 2 and negative in AVR. Okay, go on.
Yes, lead number 1 is positive. Yes, positive, and AVF is positive also. Positive. Then QRS, you will see.
Okay, this means lead number 2 is the biggest one, so it's around 60, but lead number 3 is bigger than lead number 3, so it's 70, the axis, okay? All right, good. PR interval.
PR interval is normal.
Are you sure?
I think so.
Right behind the P, the QRS starting. So there is no PR distance. Plus, if you looking at, you do see a little notch, okay? If I want to draw it, this is a P and it's already starting, okay? P
Okay.
and what does it mean?
Left posterior block?
No,
Oh, sorry. Then
PR short. When the PR is short, what does it mean? That's a pre-excitation syndrome.
yes.
So the AV conduction is shorter than should be. So the pre-excitation syndrome, QRS is wide, and you do have the delta wave. So this is a WPW, yes?
Yes.
And which type? V1 is negative. That's a B type.
B type.
Okay. Now let's
Mhm.
see this one. Yes, that would be great. Okay. Clear all drawing. Oops. All right. Let's see, that should be the last one. Maria, let's do it.
Okay. So we look at the rhythm.
Mm-hmm.
It looks to be pretty rhythmic.
Okay, that's rhythmic. Good. The rate is around 1, 2, 3, 4.
So like 75 heart rate.
Correct. Okay. Good.
And then we look whether it's a normal sinus rhythm.
Whether this is sinus rhythm or not. Okay.
Yeah.
All right. Do we have P waves? Well, very barely you can see the P waves, I would say it, but this is, for example, a P wave. This is a P wave here. Here is almost, you don't see because very noisily the background, okay? This
Yeah.
is, all right. So,
Normal.
okay,
Sinus
that's a
rhythm.
sinus rhythm. It can be a sinus rhythm because it's regular. The
And then
PR distance is very difficult to look at it, but if you concentrate on this side, I try to magnify it, okay? I try to magnify. As you do see that that's a P, and that's the,
so it's also very short. Like the
okay, and this looks like that's a WPW syndrome again, but which type?
Um, one second.
It's typical, looks like it's a right bundle bench block. So you do have positivity in lead number V1. That means A type.
Okay, type.
That's an A type. Okay.
Yeah.
Good. All right. Well,